I'm going to try to go fast.
Go ahead and introduce yourself.
My name's Tyler Weaver. I write software at Picnic Robotics with Chris. Chris talked a lot about all the useful things you needed to use to be able to use package managers. No surprise, I'm also a huge fan of package managers, or at least the idea of them. Actual implementations, I have opinions. We can talk about it. Anyway, my talk is called Reading Ranges. Don't take my word for it. We're going to read some code today. And I told somebody that I'm hoping for like 9 out of 10 to 10 out of 10 peanut galleries, so yell at me for anything I do wrong.
You can do that.
Hopefully it'll be entertaining.
Yeah.
Yeah, okay. So first, I'm going to tell a story of how I got here. So I, middle of last year, started playing with ranges. A lot of you probably played with it before then or since then or whatever. And one of the talks I watched is this talk by Barry comparing different ranges models. I was also learning Rust at the same time. And I was really confused by this talk, and we'll come back to it. The other things I'm going to list here are things that I've read that helped me understand both how to use them and how they're implemented, and a lot of the trade-offs. The concepts talk from, or a paper from Straustrup was really helpful for me to understand concepts. Also, there are a handful of talks that were helpful. Ranges v3. The docs talk about how it's like woefully incomplete, but the docs are very useful in Ranges v3, and the code is actually really interesting. Encourage anyone to go read it. And then probably most important in what we're going to do today is we're going to look at some lib standard C++ code. I'll be really upfront with like one of the messages that I'm trying to get across is that this code often appears really unapproachable, or it's easy to assume that it's unapproachable when it's not. And it's you can learn a lot, or you can answer a lot of your own questions by reading it. And the rest of iterator is important. We'll get back to it. And then I suggested that I was going to give this, or talk to Jason about giving this talk. And around the same time, I was having a lot of thoughts of like, well, maybe I'm just using it wrong, right? Some people joke that I've heard the joke that the motto of C++ is you're holding it wrong. And so I was pretty sure that I thought I found something interesting, but I wasn't confident that I was just I just didn't understand it. And Jason pointed to this talk by Nico and said that I shouldn't watch it before I gave this talk. Well, I went and watched it, and now I come to you with a lot more confidence that.
No, I said you should prepare your talk, then watch.
Oh, okay. Well, I did that. I watched it. Now I have a lot more confidence to tell you something is really broken, and we'll get back to some of the things I learned specifically from his thing. So we'll start with the mental model of ranges. This is my summary. Ranges are iterable types. Vectors, list, your tree thing that you implemented iterator on. Iterable types are things you can call begin and end on, and get something you can increment and dereference. Right? We work in a duck type language. This is how it works. Views and non-owning iterable types are composable. The views are non-owning types. So think a struct with a pointer in it that you can also call begin and end on, and it'll do something useful. And really the thing that I want to point at is they're supposed to be lazily evaluated. It's not always true. So we're going to talk about this code example. This is the minimal example of this is the thing that I found. I found writing a lot of code that's would be really noisy, and it would be hard to find this in it. But somebody want to tell me what these print? We'll start with line 6. Does 6 make sense? Somebody want to volunteer and tell me what line 6 prints? What numbers? 024. Okay, 024. Yeah. Line 10.
You already evaluated at 1. 0, 1.
So line 10 is printing my list, right? So what's it going to print?
Oh, but you insert.
But I inserted into my list. Good catch. Well, right. So what is it? I'll give you a hint. Line 8 is inserting 3 2s in the front of my list. What is? So what do you think? What do you think line 10 prints? Yeah. Okay. That's really straightforward. Line 11. What does it print?
No, it's going to be 2024. No, it just only prints the word. I think the already filtered caches the first value. No. The problem is that we've already evaluated the range once. That's what I'm saying. It filter caches the first value. No. But it's immutable. It's already been evaluated once. That's nothing. Right?
So that is an interesting point, and that I'll get back to that later. But that's the wrong intuition. I'll show you what 11 prints. What do you think 14 prints? Does anyone have any theories about what it prints after you call the copy constructor on this view object? Okay, so this is what it prints, and these are the You're right about it caches begin. So it's going to cache begin when it's evaluated on 6, and then 10, and then 11. It's not lazily evaluated. It's going to reuse that begin, and it's going to give you 0, 2, 4. But when you call the copy constructor, it's going to reset the cache. And we're going to go look at the code and try to understand why.
Is that specified on standard?
We'll get there. So this is all I rent. For context, this is on GCC trunk, run on Godbolt.
I have a question. If you have a const range view, you can't iterate over it.
That's not true. We're going to get to that.
It doesn't compile when I've tried to do it.
It sometimes doesn't compile.
Okay.
We're also going to get to what the author of this library thinks of const. We're going to start with drop view. Drop view is a lot simpler than filter, but it does the same thing. So a view is a struct thing or class thing. It's a type, and this is the beginning of the implementation in GCC. The first thing I want to point out is the beginning here, this template. It doesn't say type name there, it says view. Somebody want to volunteer what that is? That's a concept, okay. So this is the concept definition. It's in another file, but this is the concept definition. The idea of concepts being a way to make two things plug compatible, I think, is really one of the best ways to describe what it's doing. So view is there down at the bottom. The first thing it is a range defined there at the top. It's a type that you can pass into ranges begin and ranges end. We'll get back to why those even exist. And then it's movable. Movable is another concept. It has the move constructor and some other things. And then enable view is kind of an interesting one. I listed it right there. It's a compile time bool, which is what concepts are too. That is either this type is derived from view base, which is this empty struct, which I couldn't find used anywhere else. And so this is maybe like an extension point of some sort. I also couldn't find anything about view base in the standard. This is weird. But the second one is really important, is derived from view interface. We're going to get to that. That one is important. So it's one of those two. Drop view, like all the other views, inherit from this view interface thing. Somebody want to volunteer what this is? There's a name for this. Yeah, it's CRTP. CRTP is kind of confusing. It's this circular template relationship thing. It's going to pass the type of the class that we're defining, drop view, with the type that it was given as a template argument into its the base class. Okay, so we're going to look at this one, view interface. View interface it's important to understand what this does because it is going to define a bunch of methods that are implemented on all of the, through the CRTP thing, on all the views. So for something to be a view, one of the key ways for it to be a view is to inherit from this CRTP class. And so the first thing I want to point out is, so we're going to start a new technique, and the new technique, which I find really helpful when reading this sort of code or reading other library code that I want to understand, is I'll take a chunk of it and I'll throw it in my text editor, and I'll start looking for things that look like they're just added everywhere, and then I know what they do, and I'll figure out it, and I'll just delete them, and so that I can get rid of some of the noise. And this is the first thing: no accept, no accept. This is forwarding no accept. You can look up how to do it. This is all this is doing is just making sure this is, you know, if the derived types are no accept in these ways, then so are the or the template type. Anyway, whatever. No accept is forwarded. It's all over the standard library. So you delete that, and 30% of the code goes away in this thing. Actually, it's kind of crazy. The next thing is static asserts to make sure this is being used as a CRTP class, because if you used it in some other way, you might be surprised with maybe a less helpful error. So that's what these static asserts are used. They're all through this thing. So we're gonna get rid of that. We get rid of another huge chunk of the code, and we're down to these private methods. These private methods, so this is kind of the one of the key points to how CRTP works, or part of the pattern of CRTP, is you often need some way of, you have to cast to the derived type. So the base type has to be able to get pointers to the derived type so that it can then ask the compiler questions about the derived type that then lead to certain methods that it's going to either implement or not implement. And so these two first ones give us the reference and the const ref to the derived type, and then these second two are ways of asking whether this thing we derived from is empty and what its size is. We're going to use those. All right. So here is the public interface with that stuff removed. We have a series of functions here that you may recognize. Remember, concepts are about things being plug compatible. What does this look like? Don't look at the body of how it's implemented, but look at these functions: empty, cast a bool, data. What is this? It's like vector. It's like list. You know, I don't have the answer. I'm sorry. So the next thing I want to point out is there's a require statement on all of these, and these require statements, thus, you know, concepts. The concepts are using the derived type and then seeing if this statement is like well formed, and then if it is, then you get that method. So all of these, if you go back all the way out, the range or the view type is going to take in a template parameter that's going to be passed to this, that then if those expressions are well formed on that template parameter, every view in the views library has those functions, which makes all views plug compatible in a really specific way. If I remove the details of how they're implemented, these functions aren't actually that interesting in how they're implemented. Again, right, we're looking at these requires clause. And I'll scroll down through them. We have empty, we have cast a bool, we have data, we have size, we have front, back, and the square bracket operator. So, and not all of them are always implemented, right? Square bracket operator depends on random access range. So, right, you can't do square bracket operator on list. Yeah.
Okay, good, thank you.
Okay. So, back to drop view. I'm going to do the same thing, except for, in the sake of time, I'm just going to delete a bunch of code that is uninteresting. We're going to focus on some of the interesting bits. These first two statements are in the private section of this class. Needs cache begin is a const expr rule that this statement is going to repeat itself. You're going to see random access range of the template parameter that's passed into the drop view, and it's a sized range. If it's not that, then we cache. So if you go back to my example, one of the things in my example is, right, I was using a list. List is not a random access range. If I use a vector, the code is unsurprising. But if, I don't know, I tend to think one of the really powerful things about C++ is we can have the abstractions we want, and in a lot of cases, lists and other sorts of containers like that are really helpful, non-random access ones. So in the non-random access case, we set this needs cache begin to true. The second one is where you cache it. It's another like detailed struct thing. And the important thing is that it passes in needs cache begin as a template argument, which tells it the size of the thing. And if it's false, then it's 0. And the second is like what it's going to store. And in this case, it's this cache position thing. And cache position is specifically an iterator type derived from the VP thing. All right, so we have two implementations of begin, and you only get one of these. The bottom one you get when you have random access range and size range. Again, kind of like needs cache begin is false. You get the second one. The middle one is the interesting one, and it's why this behavior happens. The trade-off of this is people who, this is a great feature for funding C++ advice books, I think. And making code reviews complicated. We're going to talk about why they did this. And why they did this, I think, is a corner case that it's important to optimize for, or important to provide an optimization for, but doing it by default, I think, was wrong. At least it's not user-friendly. So yeah, here's the slide again. This shows what, what it is. Anyway, that's the meat of the reading section, and now we're going to talk about some of the stuff that I was a lot less confident about. This is the stuff I had to dig up because I was like, why is it behaving this way? And then I learned, and then, well, anyway. These are the ones in C++ 20 that do it. I think filter is probably one of the most important views, and the fact that it has this behavior, in my opinion, well, I think it's pretty bad, but you ask why. So here is from the working paper, and I have underlined the important word, or the important series of words, amortized constant time complexity. We know that from using pushback in vector, right? Most of the time it doesn't allocate, and you get to take advantage of that because you don't call pushback only when it allocates. In this case, we're calling begin, and it's doing this every time. Every time we want it to behave like this. The corner case, which is covered up by my mouse that I'm going to move, is that if you combine reverse view and drop view, this turns into this nasty complexity problem. I think this could have been solved by detecting whether you're constructing a drop view from a reverse view or a reverse view from a drop view, and then giving this behavior maybe, or even just having a different version of drop view, a caching drop view, and telling people in the corner case where like, oh, your performance is worse than you expected, there's this option over here in the corner, instead of doing this by default. This, I think, is a case of making a rule and then hamstringing yourself by the rule. This amortized constant time begin. This rule makes a lot of sense if you talk about containers, but once you introduce the idea of views, it becomes unfriendly. Okay, there's a few more things that are broken. It should make plain sense that this compiles and works just fine, right? That there's no views or anything fishy in here, no modern code. I have a function I called print front or. It's going to print the front of a collection and take a constant reference to the collection and some default value that it'll print otherwise. What if I want to drop the first two? That shouldn't, wait, that doesn't compile. And it doesn't compile because it discards qualifiers when you call empty. And it's because empty is going to try to const cast. Yeah, you can't make a constant reference to a view most of the time. There's this one. It should be obvious that this shouldn't compile. Do you want to guess what happens when I put a view in there? This is going to be great for selling C++ advice books.
Where did the constant cast happen?
That compiles.
Well, does it compile in 23? Because there was a paper fixing cbegin.
I don't know. I couldn't find an implementation I could test it on. This compiles with ranges v3 too.
Going back a little bit, should one of our takeaways be that we shouldn't let the lifetime of views be very long if they have this issue where sometimes things get cached and sometimes don't? You don't have to deal with caching if you just let things only have a lifetime of the expression in which they're used.
Yeah, so that is the explicit position of a handful of people who give talks about how to use views, is that they should only be used as temporaries.
I think this is the first time I've seen a view actually like kept on the stack. I usually see these like massive expressions,
so I think that's
10 lines.
Yeah, so I think that's one area where like maybe I didn't understand the intent when I first started trying to use views. Is my understanding of views being lazily evaluated, it would be really nice if I could make a struct with a bunch of views in it, and those views pointed to some collection, and then the collection gets updated in some way, and then I can use the views as sort of like functions that access the collection through a transform of some sort. Obviously, that's not the intended use.
I would say you can still do that. Just in workflow. Instead of store view, store function.
Yeah, so the workaround is, yeah, you just make functions that make temporary views, but.
I want to ask about the reverse of drop.
The reverse of drop.
When you had before, like reverse of a drop could be implemented as a take of a reverse, right?
Yeah, and that will cache.
Yeah.
And that doesn't have
so if you call, so this is the difference between, like, I saw a thing on Twitter recently, you should never make the types yourself. You should always call the functions, right? Because the functions can do things like that. In particular, if you call reverse of reverse, the function can special case that and just return the original view. Whereas if you're building the type, it has to wrap it.
So I didn't bring that point up, and that's a really critical point. One of the coolest parts of the machinery of ranges is reading about how the functions work and work into the types. And there's all sorts of special casing and cool stuff being done in the functions that they can build optimizations in that way. And that's one way this could be fixed or addressed. No, that's an excellent point. That you could special case it that way because you would know the type, because the type would be a template. Yep. Yeah. Exactly.
Okay, so theoretically, Visual Studio does implement the fix that you're referring to, and that code does still compile.
Yeah, I don't know. I couldn't find an implementation where it didn't.
So is it possible, sorry, I just want to ask this,
Is it possible to have a bidirectional seems overly constrained, right? Because I can build an infinite range with iota, and I can make that bidirectional because I know how to decrement as well as increment.
Yeah.
But there's no start point to work from. I can only go backwards while I'm iterating it. I can't enumerate it backwards.
Yeah.
But I don't think there's a concept that covers that.
No, I don't think, I agree. There are special kinds of generated ranges like iota that you can do that because of what we know about how it behaves. I wanted to put this up here because this is from the documentation of ranges v3, is what the author of ranges thinks of const and also of containers. Remember plug compatibility. One thing that I was pointing out here is that views are not plug compatible with containers, even though they express the same interface, which I think is a nasty corner case that didn't have to be, but Mr. Niebler didn't think so. So they have the same interface as containers. There's a temptation to think about them as containers, but they are not with regard to constness. This idea of interior immutability. They behave like iterators and pointers, which I disagree with. Pointers are a special feature of the language that has both interior and exterior constantness. Iterators have, there's colors of iterators. There's const iterators and not const iterators. And that is the solution that was glued onto views, I think. In my opinion, I'm not a huge fan of it, but I think you should be able to make const views, but there is the const view. So you can actually, I think this comes in 23, there's this as const function that will give you a view that you can store as const and you can pass as const. I think that we didn't have to make const a color.
I have to redact my last statement. I did not have the current preview release of Visual Studio installed.
So it doesn't compile?
I don't know yet,
Oh.
but I can't say with confidence that it did.
None of the versions on Godbolt did.
Yeah, you can't trust that right now.
Oh.
It's not, I'm not going blind. It's not Matt's fault, just for the record.
Okay. I don't know. I really appreciate Godbolt. It makes things way easier to test. I don't know how to build GCC on trunk locally. Or I don't have a package manager that'll give it to me. So that I know of. Yeah, he said just don't use const. Like const isn't a feature. That's his opinion. So here's the mental model of views. They are non-owning iterable types that are composable. Cache the begin pointer sometimes. Sometimes they're lazily evaluated, sometimes not. Can't be passed as const and cast away const. I don't think that's very nice. So this is a link to Nico's talk and his library he's working on that addresses these problems. And that's the end of the main part of my talk. I have opinions as to how this could have been fixed or should have been fixed.
So I think there's still a question which we didn't really answer, which is, so my mental model is basically a view as like a container because it has a beginning and an end. And in the beginning, you showed us an example where you created a view, and then when you called the copy constructor, so when you didn't call the copy constructor, that filter was cache.
Yep.
When you called the copy constructor, it got the actual beginning. Which means that it's evaluating the sequence of views.
Yeah, so when you call the copy constructor, that's when it's going to cache again. It'll cache in the new object. It'll start the cache, so it still has the view has the pointer to the list, right? But it does, so it's going to recalculate that in the copy constructor, which is, I think, really confusing, but it's what it does.
And I guess the second part of that is that if, so we were trying to reduce the runtime complexity of, I don't know, it's filter and reverse, or I don't remember.
Yeah.
But if you have a bunch of views and you were doing some sort of specialization based off of whether you're doing a reverse on a filter or whatever the sequence would be,
yep.
Wouldn't that increase the complexity during compilation? Because now if you have n views, you have to look at n-1. So, and that n-1 has to look at n-2. So
in
during the compilation.
Yeah, during the compilation, but you only have to do that on each of the ones that like negatively interact with each other. I don't know. I think the point where we cared about compile time complexity passed a long time ago. Sorry, don't include these libraries if you care about that.
I actually thought that when I saw static insert. Like, is that really necessary for that?
So the one interesting anecdote is that for some of my, when I was trying to build an example for this, it actually forced me to write to really reduce my example, because most of my examples wouldn't compile on Godbolt without timing out. So that's why we looked at drop and not filter.
You can barely compile a regex example.
Yeah, I don't know. Regex is everybody's favorite punching bag, but I don't know. I don't have much to say about that. Yeah, this is my opinion is how we should have fixed this. I think we should have real users giving feedback, and the way to do that is packaging. And we need a package standard. And standardizing the libraries should happen after the libraries become standard, not after somebody fights for years arguing to 300 people that it should be standard. Or appended to a PDF that then somebody implements. I don't know. Think about it however you like. Say what you want.
No, I just don't want to necessarily be live on the microphone.
Eric's work was for to create ranges.
Yes.
Was funded by the ISO C++ Foundation.
Yes.
Okay.
But because we don't have a packaging standard, it didn't see adoption before. It didn't see enough adoption to address these issues.
I thought it was funded by ISO C++ Foundation.
It's one of the, I think it's the only thing that was.
I think it was the only thing.
Yeah, my understanding is it's like the ISO Foundation paid him to finish the library. It's one of the few, the only case I know of that this happened. I think libraries should become standard through users using them before they get added to the STL. That's my salty take.
Do you want this live on the internet when we're done?
Yeah, I don't mind. I'm plenty salty on the internet. My last salty take is maybe even more controversial, and that is okay, here's my last salty take, and my last salty take is that actually reading code isn't as painful as many people would like to believe, and we naturally avoid it, but we should, especially when we give talks about code, we should read it. I was so confused by this talk by Barry, because he purports to talk a lot about Rust iterators, and I had just finished reading the Rust book. And so I even went back through the history of the Rust standard library to try to figure out like what version of the Rust iterators is he talking about. And it wasn't until I talked to other people and found out that he was actually talking about a library that a friend of his implemented that purported to implement Rust iterators, not about Rust iterators. And I think that was a bad game of telephone. And that if people are going to give comparisons like this, they should go read the source library, because it's not actually that hard. and stop playing games of telephone where you read a reference book that was written by somebody who watched a talk that talked to his friend who had an ill-formed opinion about something somebody else told him. You should just go read the source. Like, we write code that depends on these big open source libraries. It's not that hard to read the source. His whole argument here over Rust is that it's all implemented in this term as a single next function that does iteration and dereferencing in a single step. That's not correct. And that's my salty take, that he should have read the Rust iterator library. It's not that crazy. Rust actually does have problems. One is that I find annoying, is kind of similar to the C++ one. It has 3 colors of iterators, similar to all the basic problems. It has, like, for every iterator, you have to implement like 3 different types, one that is immutable and one that's mutable and one that does destructive moves. And the last little bit there is about how, yeah, the way the trait system works, it does the same thing, where you can separate incrementing and dereferencing in the cases where that is optimal for your algorithm, and where it's feasible given the container type you have. Anyway, that's the whole thing. I don't know. Does anybody have any objections to this? What'd you say? They need deducing this so bad.
About the packaging standard libraries, wasn't Boost that? I mean, Boost used to standardize the libraries before they became standard.
Right.
Yes. Yeah, that was the path, and because Boost has wide adoption, Boost solves this problem without package managers. Like, you get your library into Boost, a bunch of people use it, then we get real feedback, and then eventually it becomes standard.
Nowadays, I don't see Boost. I don't know. I might be not familiar or in the domain anymore, but Boost doesn't being used as much anymore. Maybe, I don't know.
We use it heavily.
I'm not saying people don't use it. I'm saying when I use training, I use it.
For example, we don't, which I want to introduce.
There are newer libraries coming into Boost, but it is fewer and fewer. I do have a question.
Yeah.
You mentioned that he was basing it off of a iterator library that's like Rust. Was that an iterator library in C++ or was
Yes.
it in Rust? Oh, interesting.
Yeah, so somebody implemented what their copy of Rust iterator in C++, and they implemented, like, I guess, like, Rust has this whole trait thing, and maybe that was confusing, and so they did just the next function, and they didn't do the increment thing. Rust has these functions called nth is one of them that will, like, advance the iterator by a certain amount without dereferencing it, and there's other things. Yeah, it's implemented on vector, but not on list. And anyway.
I'm just shaken by the cbegin example. What was exactly supposed to be constant there? Like, the name says cbegin, right?
Yeah, so cbegin is a function that uses argument lookup thing. Let's see if I can find it. Did I miss it? I went right. Yeah, I went right past it. I'm sorry. Right there. It uses argument lookup to be able to call the const version of the begin iterator, or the begin function method that returns the iterator, and then gives you an iterator that should be constant.
It should always be, it should theoretically always be
It's a scary example. Yeah, it's not an iterator that's a constant. It's an iterator over a constant.
When you reference it, you get a constant.
This example is very upsetting. It's very upsetting.
So 23, I'm learning 23 fixed it.
I mean, so there's specific, but there's definitely a paper that says something like cbegin should always
Okay.
It has been accepted that it's the exact same. So it's one of the virus.
Oh.
Yeah, so the paper is called cbegin should always return a constant iterator. It was accepted.
Okay.
So it's cbegin's problem, I think.
I think it's a side effect of the fact that all views try to cast away const. But I don't entirely understand it. Oh, well, that's cool. So that's another thing. I have to say that like that talk was really helpful for me understanding C++ ranges and how it's implemented. And he obviously really understands these details and has invested a lot into it. And he made this mistake, which really confused me. And my salty take is that we should all be reading the libraries we depend on. There's a lot to learn from doing that. And it can also help us compare things more accurately. What'd you say?
Sometimes the bugs are understandable.
Yeah, so yeah, in the case of the drop thing, I feel like the bug is in the standard, but that's, I'm just one opinion. Like, I mean, there does seem to be this bias towards like make the if there's an edge case where you can create like really bad performance, then we should be very careful about handling that correctly. And that seems like it was probably a higher priority than making filter behave the way people would expect.
I'm sorry, every time I look like I might want to speak, Tim has the mic.
He's ready to give it to you.
I see what's happening here, yeah, because it's the cbegin on the view does not return a const thing unless it has to. So it goes 2 layers deep.
Oh.
So I mean the const begin on the view.
Oh, okay.
Is the anyhow.
Yeah, I mean,
it's behaving more like shared pointers get.
Oh, okay.
Shared pointer to a non-const thing.
Yes. Oh, okay. So it's treating it like it's a, yeah. And that maybe justifies better what is written in the ranges docs about how it behaves like a pointer or a pointer type, like shared pointer behaves. I think it's surprising. I think they should behave like containers, but it's just my opinion. I want to use them. I was very excited about them. I'm still going to use them. But this was surprising when I wrote some code and it didn't do what I thought it would do.
Is there a way to fix this from outside, meaning that some kind of a library view that not too much work?
I mean, I think the way to fix this from the outside is you use a package manager and you include somebody's library that's not ranges that doesn't have this behavior.
You're doubling down on the salty take.
Like my salty take is package managers is how we should distribute libraries to users so we get feedback on them.
Yeah, save little software brands.
Okay. I mean, the Nico's library, it does the very boring thing of not caching. And it's like basically a copy of the standard C++ implementation without the caching. And he implements this cached, like he makes caching a color. So he has cached drop view and cached, and so that you can use that in that case. I don't know if he does the special case with the function. That would be pretty cool if he did that. So he could get the optimization, you work around that corner case. That's what I mean. It's a view type in itself. It's like a separate view type, and it's like just named. You put the cached prefix on it. So there's drop view and cached drop view. Yeah, it has decided. Yeah, that's the whole thing. I don't know. Thank you.